Hello and welcome to another wonderful presentation by Fly Guy Francois. We are going to be looking at constructively and destructively interfering with things. So let's jump right into it. So here's our essential question. How can something be in two places at once, or be two things at once? So let me explain what I'm talking about. Let's say if we have a wave, let's call it wave A, as you can see here, and we've got another wave, wave B. And let's say that wave A is traveling to the right, while wave B is traveling to the left. Well, what would exactly happen if these two waves were to, I don't know, say, invade the same space? So let's take a look at this. Okay, wave A comes in, wave B comes in. Well, this looks a little weird. We got two waves overlapping. What would actually happen here? So let's take a look. Well, if this was a transverse wave, remember that our wave represents the height or the amplitude change in terms of distance perpendicular to the wave transmission direction. So this wave right here, wave A, would be telling it to move upwards a certain amount, while wave B would be telling it to move downwards a certain amount. So that's kind of hard to explain. I mean, we're telling a piece of matter to move to two different positions at the same time, right? And if these were sound waves, longitudinal waves, then we'd be telling them to move to have different densities at the same time. How can we deal with this? Well, the answer is simple, my friends, and the name of that answer is superposition. I hope you enjoy the pun. So, what is superposition? Superposition is the combination of two waves. They result in interference of them. So what you do is you take the addition of their amplitudes at the selected points, and time is known as, and this is known as the superposition. There are two types of interference. You have constructive interference, which if we observe right here, we can see two waves when they come together and they're working together. Their amplitudes are on the same side. Effectively, the amplitudes are both have the same sign, so both positive or both negative, as the second dip down would indicate. You get a much larger wave, a combination of the two. You just add their waves together. Whereas you also have destructive interference. If they are opposite of one another, if the amplitudes are working against one another, then they are still adding together, but because one is effectively the opposite sign of the other, then you end up with an amplitude that is effectively, for all intents and purposes, negative, which is not something that we normally say. Most of the time, amplitudes are positive. But in this case, we would treat it as a negative, and they would actually have a canceling out effect. Now, it may cancel out completely, which is called complete destructive interference, or they may only subtract from each other, still leaving some version of a little wave that's going on. Now, you can also get them a little bit more complicated, and this is where we bring in the idea of the beat. So let's say we got two waves here. We got wave 1 in red, wave 2 in blue. If we look at this, they're slightly offset from one another, such that, as it indicates right here, you'd get a point of constructive interference, but a little ways down the road, you would end up with a point of destructive interference, and then another point of perfectly constructive interference, and then destructive interference. And what you would result with, if you were to send these two over on top of each other, is you would get this green wave, which is still a superposition wave, but we can see that it's changing between constructive interference and destructive interference, and the fact that it has a kind of repetitive nature to it, that has these humps, as you were, a general repeating pattern to it, that is what is known as the beat. Okay? And I'm not talking about the path that cops go on. I'm talking about musical notes. So if you hear the beat of music, this is effectively what's happening. You're seeing it hit constructive points and destructive points in the repeating pattern. That is effectively what the beat is. Okay, so beats are repeating patterns in the superposition of two or more sound waves. Most of the time, humans can only detect noticeable beats if there's a difference in wave frequencies of 7 hertz or less. So, once again, the superposition is the combination of these two waves. So this right here, our first example, would end up being a perfectly destructive interference pattern. Okay, so that would mean that it would completely cancel out to nothing. I hope you enjoyed this, and I will see you next time.